So let's start with the binary classification. What we need to add to this project is the Microsoft ML NuGet package. We can use the latest version, which is 3.0.0. It has just been released, so quite new. They have a release in every half a year in average, so we don't expect any changes soon. We can also add this Microsoft Data Analysis package. It contains the data frame class. Data frame can be used to load CSV files from disk. To be honest, the Microsoft ML library also provides CSV loader, but it is not very smart. It is very, very basic, and data frames are much more sophisticated. Data frames, for example, can join multiple CSV files or multiple tables into one big table. And as the machine learning algorithms use only one big table as inputs, then this is a very, very useful feature. Okay, this is the project file. And the source code is very simple. First, we just train the model. We create something from our data, and then we just use it to predict. Okay, let's speak a little bit about the training dataset. We have multiple sources of training datasets, not just OpenML, but also Google has a good search page for datasets. So if we come here, then we can search by format or topic or provider, but I don't really like the Google's search options, so I like the OpenML version. It has a much better, much user-friendly search engine. Let me just randomly use this diabetes dataset. We can find a short description here. It defines which column means what. So you can see that we have 8 parameters about one person, and the 9th one is if it is measured as diabetes positive or negative. The dataset itself is in a very strange format. I can open it in Visual Studio Code. You can see the same information is provided here, but we need only this part for machine learning. The first part can be deleted. It has a detailed description just as in on the web page. Right now it is not very useful for us. So what I did is I just converted the file seen previously to CSV so that we can load it with this data frame class. If the data has been loaded, then we can split the data into 2 parts. In this case, the 20% of the input data will be used for model evaluation, and the 80% will be used for training. So it is always a very useful thing to divide the input data into 2 parts. The first part, the 80%, can be used for training, and the last 20% can be used for evaluating the model. In order to do the machine learning, we need to create a small pipeline. In this case of binary classification, this pipeline contains 2 steps. The first 2 steps are data preprocessing, and the last one is the actual machine learning. What I need to mention is that the machine learning algorithm always have 2 values. The first one is the label column. This label column is if we do the prediction, which means if we use the model, then this label column will be the output of the prediction. So if we provide information to the model, then it will just decide, and the result will be loaded to this column. The feature column, it is a vector, and also it is not a real column. It is concatenated by this step. We are in a very lucky state because all the input values are in numeric format, so we don't need other pre-processing steps. We just create a vector from these values. So this is what this concatenate step does. It just creates a vector. So this algorithm just takes a vector of input values and something which is the expected value, or it just provides the value, the prediction based on this vector. Okay, but what is this label? In our case, if we open the CSV file again, we can see that in this class column, we have two values, the negative and positive. These are just strings. So what we need to do, we need to convert these strings into a Boolean value. Why Boolean? Because the binary classification method or the binary classification algorithm works on Boolean values. So we need to convert the string values into Boolean values. The input column is this class column, and the output column is this label. Of course, this label doesn't exist up to this point, so we will just create a completely new column. This is not indicated in this CSV file because it is just, it is just something on the disk, but in the dataset, we will add the new Boolean column, and we will fill this Boolean column based on something text value. And this is true for features as well. This feature value, this feature column doesn't exist up to this point. It is just the combined values of this column here. And it is true for row to row. So as if we just created a label and the features column here, and this is true, and you can imagine an array here, and this is false, and another array here, maybe this. So you can imagine. In reality, our machine learning algorithm will just take this value and tries to determine the correlation between this vector and this Boolean value. That's all what the algorithm does. But of course, this magic doesn't happen without us, so we need to define the pipeline. Okay, so having defined the pipeline, we can use this fit method on this trained dataset to create the model. The model contains the logic how we can create this Boolean value based on the input values. Actually, the parameters of an algorithm. We will see what the content of this model is. So this line will train the model. This will be the most time consumption line in our code. The next one just creates evaluation data based on the test set. This is just the 20% of the input data. The input data is not too much. You can see less than 1,000. We have less than 1,000 lines. So it is about 200 lines. We need to transform it. This just does the preprocessing steps, but not the machine learning step here. So we just create the evaluation data and we do the evaluation based on this data. Later on, we just save the model into a zip file so that we can examine it. and we can consume it in a later step in use the model method. So we just save the model to the disk. Technically, we need to do the training only once. So if we have a trained model, then we don't need to retrain it again and again. Of course, if we have other and new input data, then we can retrain the model, but usually the world doesn't. And in the end, we just tell something about the accuracy of this model. Okay, how can we consume this model.zip? Very, very simple. We create context. The context contains everything about the current steps. We can load the model from the disk, from the zip file, and we can create a prediction engine. As you can see, the prediction engine, we didn't need to specify too much things here. Of course, it is strongly typed, but the lots of types are inferred from the context and from the steps here. But this is not true for this step. So we need to exactly specify the input data and the output data if we want to create this prediction engine. Let's check what in this input data is. Surprisingly, we have exactly the same properties as the columns in the CSV file. I specified the column names. It is a very, very good practice to specify the column names, because otherwise ML.NET can be confused, and sometimes we need to change something, and maybe we don't want to change the properties themselves, just the attributes. The output data is a Boolean value, so it has the predicted label. It can be, of course, anything we want, but the type of this must be Boolean, because the model will output if somebody is diabetes positive or negative. So it is a Boolean value. And it has a predicted label name. After doing the prediction, then the result of the prediction will be put into the property that has the column name of predicted label. We can, of course, change this label here. It can be anything, but it is not a good idea because, you know, it is just tradition. So we just create the prediction engine, and it is very, very simple to use the prediction engine. It just has one method, the predict, and if we provide the input data, then we will receive prediction. And let's see how it works in real life. Let me just put one breakpoint here. If I press F10, then our code will stop at this point. Very good. F10. Okay, we have just loaded the data and split into two parts. Not very interesting. We have 8 rows here, and the last one is some kind of text. String data doesn't really matter because we will just convert it into Boolean. We have just built the pipeline. It doesn't do anything. It is like link or linku, as in Hungarian we tend to say. It doesn't do anything until we call the fit method here. It tends to be very time consuming, especially for image processing or text processing, but as our input data is in numeric format, it doesn't take too much time. Okay, we need to transform the data so that we can use it in evaluation. Let's save the model and let's check the accuracy of the model is 77%. I don't know if it is good or bad, but yeah, it can be good or can be bad based on our use case. So how we can consume this model? We just create the ML context and load the model.zip, create the prediction engine, And if we provide the input data, F10, then we have the prediction here, and you can see that prediction label is a Boolean, and this person is false for diabetes, and the other person, it will be true. Okay, excellent. So it seems to work.